Hello, welcome back. Today we're going to do something different. So Elias has built this thing called Better Benchmark, and I promised him that I would review it and give feedback. And so we're going to do this together today. So what have I done? So I've gone ahead and asked Claude to review it so that it has some context. And then what we're going to do is we're going to read through the README. And then we're gonna come up with some questions, and then we're gonna answer our questions, and then that'll be it. Okay, so what is Better Benchmark? Standalone kernel micro benchmark infrastructure for torch composition. Extracts fused kernel regions from real model compilations as lightweight self-contained repros, then benchmarks them against memory bandwidth, speed of light with proper GPU isolation and lock-safe parallel execution. Okay. So my understanding of what this is doing is it's going through like Torchbench or Hugging Face models, and it's going to just extract subgraphs from those models that it can use as standalone repros. What this does, kernel extraction, captures post-grad FX graphs, partitions fusible nodes into subgraphs, emits one standalone NN module per kernel region, saves both post-grad graphs and per kernel repro so you can repartition without rerunning the models. I see. So we save the full graph, and then we can kind of partition afterwards. Okay. Deduplication, we do content adjust hashing. Same kernel pattern from different models as one canonical repro. So I guess it's kind of like the isomorphic thing, where like if you can do some sort of isomorphic hash, then for example, if you have an attention block across the same attention block in different models, you can kind of deduplicate in this way. That makes sense. Multi-shape benchmarking. Each repro supports multiple input shapes from different models via automatic shape parameterization. Strides and X-bounded memory formats preserved. Okay. Parallel benchmark runner. Persistent workers per GPU. What does this mean? What does mean? Overlap repro compilation, exclusive lock for timing isolation, okay. Qtgraph replay, worker recovery on Q errors, okay. Incremental updates, merge into pouches an existing baseline with re-benchmark results without rerunning everything. Okay. Okay, this is not that interesting to me. Okay, so what I'm interested in is how does he actually extract it? Like, okay, hold on. Each GPU gets a dedicated worker subprocess that stays alive. Okay, I see. Okay. So what I'm interested in is the end-to-end life cycle. Can you take me through how we get the models? Is it Torchbench? Is it Hugging Face? What is the entry point? Are there phases? E.g., is there model capture and then I manually run a partitioner or something else? Okay, and while Claude is going, let us try and answer this question ourselves. So, oh my God, repros. Repros has canonical, and it has models. Okay. Torchbench says inference and train. Wow, this is actually quite comprehensive. Interesting. Okay, so it captures the full postgrad models for each one of these. That makes sense. Models. And and the canonical, I guess canonical is like subgraphs, I would guess. Repro.py. This is pretty cool. Shapes config. How's shapes config used? I wonder if this is the same across shapes. 1536, 128, 128. No, I wonder how he's getting this. How is shapes config derived? Okay, here's the full end-to-end lifecycle broken into phases. Scripts recaptured torchbench. Recapture. Each script loads a model plus makes dummy inputs. Okay, so let us see how he did this. So scripts recapture torchbench directly imports from torchbench. Capture torchbench model. Temporary capture for merge. Is this just creating a temporary directory? No. Okay. Benchmark class. Interesting. So it seems like I'm not actually familiar with this install capture hook thing. Okay. So the way they do it is that they set this postgrad custom pass to this capture pass. Oh, that's interesting. Okay. All right. So I guess to recap, he basically has a bespoke script for each type of model provider, kind of. So if he gets the models from Torchbench, he uses this thing. If he gets it from Hugging Face, he uses this thing. If he gets it from Tim, he uses this thing. And then the basic idea is, there's some like setup, but at a high level, he's setting this inductor config.postgrad custom prepass to this thing, which is defined here. And basically what happens in Torch Compile is after, we do the graph capture and functionalization and AOT autograd and blah, 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 blah. There's a entry point where the compiler will invoke a custom user pass if this postgrad custom prepass is defined. And so what happens is this function, this hook will get called with the fx graph at that point in time, And then this is where Elias can kind of capture it. Okay, that makes sense. Okay, so I think that makes sense. So I guess, why don't we ask this? And then the other thing I'm curious about is, where is the code that partitions the captured graph? Okay, so shapes config is built in captureHooks.py inside generate read profile. It's derived directly from there. Oh, I see. So this is just looking at kind of like the shapes that we saw at compile time. But then how does the dynamic shapes work? Each repro supports multiple input shapes. Okay, I don't think it's doing dynamic shapes. I think it's just saying if there's multiple tensors, there's multiple shapes. Okay, where is the code that partitions the captured graph? So it's probably somewhere in scripts. CaptureHook.py. What is the full path of CaptureHook.py? Oh, I guess I can also just do this. I should do this more often. La la la. Capability-based partitioner. Okay, this is interesting. So, is this partitioner guaranteed to find us all the possible fusions? I always thought that fusions were tricky because there are multiple ways to do fusions. And once you go down one path, it closes off fusion opportunities for others, e.g. A, B, and A, C. If we fuse AB, then we can't fuse AC and vice versa. It's not guaranteed. It's an over-approximation. Capability-based partitioner finds connected components of fusible nodes. So in your diamond example, if all three are fusible, they all land in one partition. Oh. It puts all three? Morally, what is the capability-based partitioner doing? How is it partitioning? I guess I should take a look at, I should look at PyTorch. Where is capability-based partitioner? Torch fx passes info partitioner. Torch fx passes info partitioner. Propose partitions. Merge partitions. Merge candidate. It's doing something simple. Connected components of supported node with a cycle prevention constraint. Lock every node in the graph and label it as supported or unsupported using the predicate you pass in. Non-supported nodes become barriers, they cut the graph. So if you have pointwise, mapmol, pointwise, pointwise, the mapmol is unsupported. So pointwise was one partition. How is this determined? How do we know some op is a pointwise or mapmol? Do we do it via an op whitelist? The predicate is feasible nodes. Is feasible nodes. Must have an inductor lowering. I see. Interesting. Okay. It's interesting that we don't fuse the, so just to be clear, we don't do mapmol epilogue fusions using this repro benchmark, or using in this repro finder. Any op in the flop registry. Yeah. Okay, all right. I think I understand this. Okay, so to summarize, hopefully that was interesting. I don't know if this was interesting, but at a high level, what did Elias do? He created this better benchmark that does graph capture across things like Hugging Face and Torchbench. And then he has this partitioner, this capability-based partitioner that morally does a few things. It uses the inductor lowerings to figure out what's fusible. It uses whether or not an op has a flop counter to determine if it's not fusible. Notably, mapmols are not fusible in this regime. And then something about fallbacks. And then once he's done with all of that, then what he ends up having is it's kind of weird that this one doesn't have one, but he's able to just generate these standalone repro files. Yeah. And then I'm also guessing somewhere he has some way to run all of these and aggregate the statistics and stuff like that. Okay, cool. Well, I think that was kind of interesting. I'll see you in the next one.